Okay, let's start with that. Can you hear me? Can you hear me? Okay, thank you. Okay, let's start. So today's session, very important session that is about division algorithm and finding unknowns. Okay. So this is very important session because we need to advance our skill on polynomials. Okay, let's see what is that. You consider this type of expression x plus 1 squared and x squared plus 2x plus 1. Okay. Consider x plus 1 squared, and x squared plus 2x plus 1. X squared plus 2x plus 1. These are just polynomials. No? These are polynomials. Okay. So if we know mathematics, then we can say they are same. If we know mathematics, then we can say they are same. X plus 1 squared equal x squared plus 2x plus 1. Okay. Especially we say this is identical, not equal. We say identical. That sign represent identical sign. Identical sign. Okay. Then here when you consider x equals 0, left hand side, x equals 0, then 0 plus 1 square, we get 1. Right hand side, you put x equals 0 here. 0 square 2 times 0 plus 1. We get same result 0. No? We get same result 0. Then left hand, right hand side equal. Then x equal 1, left hand side 1 plus 1 squared 4. Right hand side 1 squared plus 2 times 1 plus 1, it is 4. So take x equal minus 1. Left hand side, put minus 1 here. Minus 1 plus 1 square 0. Right hand side minus 1 square 2 times minus 1 plus 1. We get the answer 0. Then for any real value of x, so they are same, no? They are same. So now for this case, left hand, right hand side equal. Left hand side equal right hand side. For this case, left hand side equal right hand side. For this case also, left hand side equal right hand side. Then for any value of x, we can say those left hand, right hand sides are same. Then here we say this expression identical. Then further we say this one as identity. We call that is an identity. That is an identity. Okay. Then further you see this one. Further you see. Consider x plus 2 squared. Then x squared plus 4x plus 4. So this is also an identity. Equal sign, that is not wrong, but usually we write identical sign. Then for any real value of x, that is true. For any real value of x, that is true. Okay, that is an identity. Okay, then let's write one by one. Write down today's topic, identities. Identities and finding unknowns. Identities and finding unknowns. Identities and finding unknowns. Okay, just write this. Just write this. Okay, with star mark, write down. In the above expression, in the above expression, in the above expression, in the above expression, for any value of x, for any real value of x, for any real value of x, for any real value of x, both left hand and right hand sides are same. Both left hand and right hand sides are same. Therefore, which is known as an identity. Therefore, which is known as an identity. Which is known as an identity. Okay. Now say this one. 2x minus 1 identical to a times x plus b times x minus 1 kind of thing. This is an identity. Okay. Here simple x variable, a b unknown constant. Here x variable. X variable. Okay. Then here we're going to find unknowns a and b. We're going to find unknowns a and b. So here we have a specific technique. We have a specific technique. Then consider 2x minus 1 identical to a times x times b times x minus 1. So initially I told you this expression satisfies for any real value of x. That means if you substitute any x value, left hand side and right hand side, result will be same. Result will be same. So you substitute x equals 0. Substitute x equals 0. Then here 2 times 0 minus 1. Here a times 0, b times 0 minus 1. Then here minus 1 equal minus b. Then corresponding result b equal 1. B equal 1. Likewise, you can find unknowns. So similarly, you take x equals 1, then take this expression, substitute 1, 2 times 1 minus 1, a times 1, b times 1 minus 1. Then here this part 0, then a value 1. Then finally a1, b1. Here these are unknowns. Likewise, you can find unknowns. So this method we call equating coefficient. By equating coefficient, you can find unknowns. Okay. You're finding unknowns. By equating coefficients. Okay. Sorry, not by equating coefficient, by substituting. By substituting values. Okay, put that one. Now let's see. Here, when you consider this expression, here we have factors now, x minus 1. Then here you better to substitute factor 0 value. X equals 1 is the factor 0 value. So when you consider this one, x now, then the factor 0 value is 0. Then we can substitute any real value, but the best value is factor 0 value. So if you have linear factor like x minus 1, we can substitute factor 0 values. Then later we have another different technique. We will discuss it later. But anyway, you identify if we have linear factors, we better substitute factor 0 values. Okay. Now see another example. Check this one. Consider 3x plus 4. A times x minus 1, b times x plus 1. Okay, this type of identity. So now you see here this factor x minus 1, then equal to 0, x equal 1. Take this one, then x plus 1, take factor 0 value, x equal minus 1. Here these are the best values to substitute. No? Those are the best values to substitute. Now, let's substitute x equal 1. Then here 3 times 1 plus 4. Then here a times 1 minus 1. B times 1 plus 1. Then 3, 4, 7. Here 0 times a 0. B times 2. Then b value 7 over 2. Then similarly, let x equal minus 1. You better substitute these values. Then 3 times minus 1 plus 4. Here a times minus 1 minus 1. Here minus 1 plus 1 0. Minus 1 plus 1. Then here 0. Then here 1 minus 2. Then a value equal minus half. Likewise, we can find unknowns. Okay, you can substitute factor 0 values to the function. Then both left and right hand sides are same. Then we can find unknowns. Okay, this is one technique. Okay, do that example. Now let's see another example. You identify the technique. Okay, if you have any doubt, let me know. Now you better do with me this one. 4x minus 7. Better do with me. A into 2x minus 1. B into x plus 2. Okay. Then here factor 0 value. 2x minus 1, 0. X equals half. Then here factor 0 value minus 2. Factor 0 values. Then you better substitute x equal half. Then substitute here 4 into half minus 7. This will get 0. b times here half plus 2. Now simplify. Here minus 5, b into 5 over 2. Then b value minus 2. Then substitute x equal minus 2. Then because of this factor, substitute minus 2. 4 times minus 2 minus 7. A times 2 times minus 2 minus 1. Then here minus 8 minus 7 a minus 4 minus 1. Here 15. Then a value equal 3. A value equal 3. So likewise, if we have an identity, this is we call an identity. No? So in such identity, you can substitute any real value, both left hand and right hand side, the result will be same. But you better to substitute factor 0 values. You better substitute factor 0 value, then you can find unknowns. Usually we consider x variable, a, b, c, those are unknowns. Okay, do that example. Okay. Now let's do another one. Let's do another one. Okay. You better do with me. Better do with me. X squared plus x minus 1 identical to a times x minus 1. B times x minus 1 x plus 1. C times x plus 1. Okay, take this identity. Then when you see this one, here you can see here one factor, critical value 0. Here another factor, 1. Here another factor, minus 1. Then we better to substitute these values first. Then we start substituting. Now let x equal 0 first. Then here 0, here 0, here minus 1. Here 0, here 0, here b times minus 1 plus 1. Then b value we get my plus 1. Now let's substitute x equal 1. Then 1 square 1 minus 1. Here 0, 0. Here c times 1 plus 1. Then c equal 1 over 2. Now let x equal minus 1. Then here minus 1 squared, minus 1 minus 1. Here 0, here 0, 0. Here a times minus 1, minus 1, minus 1. You put bracket properly, okay? Put bracket properly. Then here minus 1 equal 2a. Then a equal half. A equal minus half. Likewise, we can obtain values, okay? We can obtain values. Then by substituting, we can find unknowns. Complete. Then I think time's enough. Then you try these questions. We have 3 questions here. I'll give you a little time. Find A and B. Find A and B. Okay. Do soon now. Do soon. Take a little time. I'll give you 2 minutes. Okay. Let's see. Here substitute x equal to. Then here 3 times 2, 6 plus 5, 11. Then A value 11 divided by 3. 11 divided by 3. Then corresponding B value substitute -1. Then -3 plus 5 plus 2. Then divide by 3. -3. Then 11 over 3, 2 over 3. 11 over 2, 11 over 3 minus 2 over 3. Okay, you take steps. I'm not getting the step. I'm just writing solution. Okay. So substitute x equal 1. Substitute x equal 1 here. -3 plus 1 minus 2. Then -2 divided by -1 plus 2. So substitute x equal 1. Then B value, substitute 2. Then here -6 plus 1 -5. -5 is B. Then for this case, substitute x equal 3. 3 plus 2, 5. Then B value, 5 divided by 6. Substitute 3, then here 6. Here 5 over 6. Then A value, substitute -3. Then here -1 divided by 6. 1 over 6. Then B value 5 over 6. A value -1 over 6. Okay, if you have any doubt, let me know. Okay, those are the solutions. Okay. Now let's move a little further. Let's move a little further. Now you consider another one. Yeah, for 2 and 3 x values. Okay. For 2 and 3, take x values to the. Here, for this case, here a times, here x plus 2. No? Here we have x minus 2. Then you substitute x equals 2. Then you have x minus 1. No? x minus 1, 0, x equal 1. Okay, then best values x equal 2 and x equal 1. X equals 2 and x equals 1. Okay, then here, when you substitute x equal to minus 3 times 2 plus 1, so here 0, b times 2 minus 1, then here b equal minus 5. Then substitute x equal 1 here, then minus 3 times 1 plus 1 equal a times 1 minus 2. Then here minus 3 minus 2, b value 2. Okay. Okay. Now let's move further. Let's move further. Now you take this, consider this example. You better do with me. 3x squared minus 2x minus 1 identical to a times x minus 1, x plus 1, b times x minus 1, x plus 1. Plus c times, yeah, take x plus 2, x plus 2, x plus 1, x plus 1. Okay. Now take this expression. Then here when you see this one, here factor 0 value 1, here factor 0 value minus 1, here factor 0 value minus 2. So we can identify there are three different factors, no? Three different linear factors. Then you better substitute x equal 1, you better do with me. Here 3 minus 2 minus 1, here 0, 0 there. 1 plus 2, 1 plus 1. Then why this find c value? Here 0. C value 0. Then substitute x equal minus 1. Then here 3 plus 2 minus 1. Here 0. Here 0. Here b times minus 1 minus 1 minus 1 plus 2. Then 2, 5, 5, 4. Then b times minus 2 times 1. Then b value here minus 2. Minus 2. Then x equal minus 2. Then here 3 times 4 minus 2 times 2 minus 1. Here 0, there 0. Minus 2 minus 1 minus 2 plus 1. Then 12 minus 12, 8, 7. A into 3 minus 3 into minus 1. Then a value 7/3. A value 7/3. Likewise, you can get the values now. So anyway, you identify if we have linear factors, then we can substitute factor 0 values now. We can substitute factor 0 values. Okay, complete. Now let's see, we have another method. That method also very important. Then previous one, value substitution technique. Now second method, coefficient equaling technique. Okay, second method. You see this one? You consider 2x minus 1 identical to a times x times b times x minus 1 kind of thing. Okay. Then here we have ax, then expand this. Here bx minus b. Then you take similar type terms together. Then when you consider here ax and bx, they are similar type terms. Then take x outside, a plus b times x minus b. Now these identities are same, no? So previous technique, we can substitute x values, no? Here also we can substitute. But further we can do, we can equate coefficients. So see, by equating coefficients, you consider x coefficient. Here this is 2, and here x coefficient a plus b. Then left side x coefficient mean numerical value in front of x, that is 2. And here right side numerical value in front of x, that is a plus b. They must be same. Then here this will be constant. So here constant minus 1 and here constant minus b. Then by this one you can find b value 1. Now b value is 1. So by this one you can find b1, then substitute. 2 equal a plus 1, then a equal 1. Likewise you can find the values. Okay. Then this is very important technique. That is the equating coefficient technique. See another example. Say another one. Consider 3x minus 4, a times x minus 1, b times x plus 1. Take this one. You follow same technique. First you have to expand the expression. Then here ax minus a plus bx plus b. Now take similar types terms together. Here a plus bx. Take these two together. Here b minus a. Now by equating coefficients, take x coefficient, here 3, here a plus b. A plus b equal 3. Then constant, here b minus a equal minus 4. Here this is another technique, okay? Then previous one we can substitute values. So this is coefficient equaling technique, okay? This is coefficient equaling technique. Now solve this. 1 plus 2. 1 plus 2 cancel a, then 2b equal minus 1, b value minus half. Then 1 minus 2, then cancel b, then here this will be 2a equal 7. Then a equals 7 over 2. Okay, 7 over 2. Okay, you better do that one. This is another technique, okay? Coefficient equaling technique. Coefficient equaling technique. Okay, do that one. Now let's do another few questions. Do with me. Here this coefficient equaling technique somewhat harder than value substitution technique. But value substitution always that is possible with linear factors, no? But this coefficient equaling technique always possible. But if we don't have any linear factor, then value substitution not that much useful. Then you better to get hybrid technique. You better to get hybrid technique. That means you just get coefficient equaling and value substitution both together. Both together. Okay, see another one. Here x squared plus x minus 1 ax plus b times x. Here c times x minus 1 kind of thing. Now here we have linear factor. Here another linear factor now. Then let's do this. Substitute x equals 0 first. Because of this factor, substitute x equals 0. Then here left side minus 1. Here this gets 0. C times here minus 1. C equal 1. Then substitute x equal 1 because of this factor. Then here 2 plus 1 minus 1. Here a plus b. Here 1, here 0. Then a plus b equal 2. Say 1. Now further you simplify this. 2x squared plus x minus 1 ax squared plus bx plus cx minus c. Then ax squared plus b plus cx minus c. Now equate coefficients. So when you consider x squared coefficient, here 2 equal a. Now we know c value, we know a value. Then you equate x coefficient. So here x coefficient 1, here x coefficient b plus c. Then c value 1, 1, b plus 1. Then b value 0. So we have a value 2, b value 0, c value 1. So that is just hybrid technique. Another hybrid technique. That means I have combined value substitution method and with coefficient equaling technique. Okay, you can connect both. Then anyway you find unknowns. Find unknowns. Okay, do that one. Okay. Now see another example. See another example. If you have any doubt, let me know. Okay, you better do with me. Then x squared plus x plus 1. Here a times ax plus b times x, c times x squared plus 1. Here take this relation. So you can substitute values. So because of this factor, you better substitute x equals 0. Substitute x equals 0. Then here 0, here 0, and here 1. Here this part gets 0. C times 0 is square times 1. Then here C value 1. Then value substitution, very strong method. Value substitution, very strong method. Okay. Then you expand this one. Here ax squared plus bx, ax squared plus bx, cx squared plus c. Then take these two together. A plus c x squared. Here bx plus c. Now equate coefficients. Then by equating coefficients, here take x squared coefficient. Here 1. Here a plus c. Then c equal 1. C equal 1. Therefore, here a plus 1. Then a value 0. A value 0. Now we know c value, a value, then equate x coefficient. Then here 1. Here x coefficient, we have only b. Then a0, b1, c1. Okay, that's how we get it. That's how we get it. Okay, do that example. Now let's take another one. Here, take this one. So I'll give you 1 minute to start. I'll give you 1 minute to start. You just try this one. 2x square minus 3x plus 1 identical with x minus 1 times ax plus b plus d times x squared plus x plus 1. You just try. Now check your answers. You better to substitute x equal 1 first. Here 2 minus 3 plus 1. Then here d 1 square 1 plus 1. Then here this part 0, no? Then d value 0. Then expand ax square plus bx minus ax minus b. Here dx squared dx plus d. A plus dx squared b minus a plus dx d minus b. Okay, now here the relation. Now equate coefficients. By equating coefficients, so x square coefficient here 2, here a plus d, a equal to x coefficient. So we know d, no? You better to get constant. Here 1, here b minus d. Then b value 1. So we have a equal to b equal 1, d equal 0. Okay. Now let's move further. Now see, here consider x square minus x plus 1, a into x times x minus 1, b into x times x plus 1, plus c into x minus 1, x plus 1. So here we have factors now. Here we have factors. Then we can substitute values. But I'm going to do here by using coefficient equivalent technique. Okay, you better do with me. Then here ax squared minus ax bx squared plus bx, see here, x square minus 1. Then take similar type terms together. A plus b plus c x squared. Here b minus a, x, b minus ax minus a. Now, by equating coefficients, now we better start with constant term because we have only one term there. No? We have only one term. By equating coefficients, constant. Here 1, so they are minus c. Then c equal minus 1. Then x, go to x, here b minus a. B minus a equal minus 1, say 1. X square, then here 1. Then here a plus b plus c. Then c equal minus 1. Then a plus b equal 2. Now we have two simultaneous equations. Then we can easily find a and b, no? Then 1 plus 2. Then cancel a 2b. 2b equal 1. Then b equal half. B equal half. Then by 2, here a, b value half equal to, then a value 3 over 2. 3 over 2. Likewise, you can get. Then previous technique, value substitution, very strong method and very speed method. But here this one somewhat slow. Value by equating coefficient, we can obtain the values. Okay, do that example. Okay. Now let's move a little further. Now we know what is an identity. No? We know what is an identity, and further we know how to find unknown constant of an identity, given identity. Now here I'm going to discuss another important thing, that is about finding quotient and remainder. Quotient and remainder, like finding unknowns. Okay. Then last day we done the things about log division. Then log division, synthetic division, those are possible to find remainder and quotient. We use them to find remainder and quotient. Then by using this type of technique, again we can find, we can use to find quotient and remainder. Okay. See this one. So let's see, x squared plus 2x minus 1, that's going to divide by x minus 1. We're going to divide by this. Then x squared plus 2x minus 1. X squared plus 2x minus 1 divided by x minus 1. So here we get quotient, remainder, x minus 1. So here quotient function, let's say qx. Then here power 2, here power 1, then quotient will be degree 1. Degree 1. Here degree 1, then r will be degree 0. Degree 0, no? Degree 0. That is division algorithm. So if it is degree 1, you write that one like ax plus b. If you have degree 0 relation, you put constant like this. Okay? Then you see here. So if you have constant you write a, b, c, linear. Write like ax plus b, px plus q, so on we can write. Quadratic. Ax squared plus bx plus c. Here px squared plus qx plus r. Likewise, we can write quadratic relation. Now, here this case, here x squared plus 2x minus 1 over x minus 1. Then multiply by x minus 1. Then x squared plus 2x minus 1. X minus 1 times ax plus b plus c. Now here the identity. This is an identity. Now by equating coefficient of value substitution, you can find a, b, c. So if you can find a, b, c, mean you can find quotient and remainder. You can find quotient and remainder, no? So that is the method. Okay. Now substitute x equal 1. Here 1 plus 2 minus 1, 0 here c. Then c equal 2. Then by equating coefficients, take x square coefficient first. Here 1. Here x square coefficient you see here a. Then get constant. Here minus 1. Here minus b plus c. Then c value 2. C value 2. B value equal 3. Put 2 here. Then b value equal 3. Therefore, you write remainder and quotient. Remainder is c, no? Quotient is ax plus b. Here it is, quotient. Ax plus b. A value 1. B value 3. That's how we get it. Okay? Do that example. If you have doubt, let me know. So previously done same thing with different method. That means using log division. Using log division, we know how to find quotient and remainder. We know how to find quotient and remainder. And further, here we divide by linear factor. No? And by synthetic division also we can find quotient and remainder. No? But here another technique. Here by using division algorithm and finding unknowns, we can find quotient and remainder. Quotient and remainder. Okay, do that example. Okay. Now let's do another one. Let's do another one. See this? X cubed 2x square minus x plus 1 divided by x minus 1. Here this relation. Okay. Then x cubed plus 2x square minus x plus 1 divided by x minus 1. Here we get quotient here now. Power 3, here power 1. 3 minus 1, 2. Then here this will be quadratic relation. Write ax squared plus bx plus c. That is quotient. Here power 3, here power 1, 3 minus 1, 2. Then degree 2 will be the quotient. So here degree 1, then degree 1 you put constant here d. Then x cubed 2x square minus x plus 1. Then cross multiply x minus 1 ax squared plus bx plus c plus d. Okay, that is our identity now. So you multiply by x minus 1, then you can get the identity. Then by previous technique, we can find solutions. Now we can find a, b, c, d values. Okay. Now you better substitute x equal 1 first, or you can expand this. Let's expand a x cubed, here bx squared minus ax squared. Then here cx minus b, x minus c plus d. Likewise, you can get the algorithm. Now equate coefficients. By equating coefficient, so you take x cubed coefficient. Here this is 1, here a. X square coefficient, here 2, here b minus a. Then a equal 1, put it here. Then b value 3. Then x, here minus 1, here c minus b. Then b equal 2, then c equal 1. Then equate x constant. Then here 1, here d minus c. Then c value 1, then d value is 2. Then remainder is this. And this is we call quotient. Okay. Then remainder is d mean 2. Then quotient. The quotient is ax square bx plus c. Ax squared plus bx plus c. Okay. Then a value is 1. B value is 2. C value is 1. That's how we get it. Okay. Then previously we found a technique called log division. So that log division technique, we can find quotient and remainder. This is another technique. So this is about finding unknowns, and this is about identity and so on. Then all combined there. Then again we can find quotient and remainder by equating coefficients. So first of all, you have to get identity. Then thereafter you can find remainder and quotient. Okay, do that. Now let's do another one. Let's do another one. Okay, if you have any doubt, let me know. So here we have to think about division algorithm and finding unknowns. Division algorithm and finding unknowns. Okay, let's do. So here I'm gonna divide x cubed plus 2x square minus plus x minus 2 by x square plus x plus 1. Okay, let's see. First you have to write division algorithm. Then power degree 3 1 divide by degree 2. Then 3 minus 2 1. Then quotient will be degree 1 relation. Put here ax plus b. Here x square plus x plus 1. Here degree 2 1. Then numerator will be, remainder will be degree 1 relation. Px plus q. Here remainder, here quotient. Here quotient, here remainder. Okay. Then likewise, you write division algorithm. So we know division algorithm. When we divide two polynomials, here upstairs degree, downstairs degree, you have to subtract. Then that value will be degree of quotient. So here power 2, no? Then 2 minus 1 will be remainder degree. Remainder degree. Likewise, you write division algorithm. Then multiply by this x squared plus x plus 1. Then x cubed 2x squared plus x minus 2 cross multiply x squared plus x plus 1 into ax plus b. Here px plus q. Okay. Now expand. Here ax cubed bx squared ax squared plus bx plus ax plus b plus px plus q. Likewise, you expand. Just expand. Okay. Then thereafter, arrange terms together. Arrange similar terms together. So here ax cubed. Then here b plus a x squared. B plus a plus b plus b plus q. Likewise, arrange similar type terms together. Now equate coefficients. By equating coefficients, take x cubed coefficient. Here 1, here 8. X square coefficient here 2, here b plus a. Then a equal 1, put it here. Then b value 1. Then x coefficient here 1. So here b plus a plus p. B plus a plus p. Here this is p. Then a plus b equal to, then p value minus 1. Then constant, here minus 2, here b plus q. Then b equal 1, q equal minus 3. Okay. Then same technique. Okay. First you have to identify division algorithm. Thereafter simplify and equate coefficients. Then anyway, now remainder. Remainder is px plus q. Then we know p minus 1. We know q minus 3. Here our remaining now. Quotient. So that is ax plus b. Ax plus b. A value 1. B value 1. Likewise, we can find remainder and quotient. So first we have to write division algorithm. Then we can proceed now. Okay. Do that example. Now you identify. This is always unique technique. Technique is unique. Function can be different. According to that, we have to write quotient and remainder. Thereafter, we have to get polynomial, then arrange terms, then equate coefficients, and so on. We can find unknowns. Then we can identify remainder and quotient. Okay, do that. If you have doubt, let me know. Okay. Now let's do another one. Let's do another one. See this? If you have doubt, let me know. So anyway, first you analyze the division, then you get degree of remainder and degree of quotient. Then write corresponding polynomial for each remainder and quotient. Thereafter, identify algorithm. Then by equating coefficient or value substitution technique, you find unknowns. Then easily we can find quotient and remainder. This method somewhat slower than the previous technique. That means long division technique very strong. Long division technique we can very simply we can find remainder and quotient. But here this one we have to equate coefficient. Then we get simultaneous equation. Then we have to solve simultaneous equation. Then this is somewhat slower than long division. But anyway, we have to practice this one because this technique very important. So for our A-level examination, there will be remainder theorem, factor theorem, and as well as division algorithm. Then this technique is the important one. Okay, now see another one. X to the power 4 plus 1 divided by x squared plus x plus 1. Here power 4 relation, power 2 relation. Here power 4 minus 2, power 2 relation, right? Px plus qx plus r. So here this is quotient. Then here x square plus x plus 1. This is quadratic, no? Then power 1 relation, write ax plus b. Then this is we call remainder. Power 2 relation, then linear will be remainder. Here power 4, power 2, difference power 2, px squared plus qx plus r will be quotient. Now multiply by this. X to the power 4 plus 1, x squared plus x plus 1. Here px squared plus qx plus r, ax plus b. Now expand and take similar type terms together. So let's see. So we have 1 x to the power 4 term. Then we have 2 x cubed terms. Here q plus p. Now further we have x square term, here p plus r plus q. X. And further we have here x square, x term r plus q plus a. So we have constant term r plus b. If you can do at once, then that is very important, okay? If you can do at once, then that is very important. But anyway, if you can't do at once, you just expand all and thereafter rearrange terms. Okay, now you can equate coefficients. No? Then by equating coefficients, so start with x to the power 4. Here 1 equal p. X to the power 3, here 0. Here p plus q. Then q equal minus 1. X to the power 2, here 0. Here p plus q plus r. Then p plus q 0. Then r value 0. X here 0. Then term is mean coefficient 0. There r plus q plus a. Then here q equal minus 1, r equal 0, then a equal 1. Then constant, here 1, there r plus b. Then b equal 1, r value 0. No? Therefore, you write remainder is ax plus b. A value 1, b value 1. Quotient px squared plus qx plus r. Then p value 1, q value -1, r value is 0. That's it. Okay. Complete. Okay. Now, so see, so when function fx, so we're going to divide this one by gx. So here say degree m Here say degree n. So for m greater than or equal n, division is possible. So by lone division, or by division algorithm, remainder, quotient can be obtained. Okay. By division algorithm, remainder and quotient can be obtained. So here qx, here this is equal to quotient, let's say qx, and here let's say remainder rx, remainder of degree n minus 1 or less, n minus 1 or less. Here quotient of degree, here mn, degree m minus n, degree m minus n. Okay, this is the thing. So by this relation you write division algorithm. By this relation you write division algorithm. So according to degree, you write corresponding polynomial for remainder and quotient. No? For remainder and quotient, you can write polynomial. So here one important thing, degree 0, constant, a constant. Degree 1, linear. Degree 2, so here we call quadratic. Quadratic. Okay. So if we have linear relation, this will be constant. If we have quadratic relation, this will be linear one. If we have cubic relation, this will be quadratic one. So on we can write. And here degree 4, degree 1, then 4 minus 1, here degree 3. Here degree 4, here degree 2, 4 minus 2, here degree 2. Then degree 5, degree 3, 5 minus 3, degree 2, quadratic relation. So here the concept. So better put that one as well. So that is our summary. That is our summary. Okay. Time's enough. Okay. Now, today I have done the things about finding unknowns by an identity. Okay. Then using that relation, we can obtain quotient and remainder. Quotient and remainder. That is very important relation. So I think that's all for today. That's all for today. Okay. We can stop now.